Hello, how's it going? Um, alright, so this next assignment is actually going to be a vocabulary assignment, guys. I just want to go over a few things that you guys should definitely know. But your assignment isn't going to be to work anything out. It's just basically watch this video, look out for some of the keywords, and then hopefully you'll be able to get your assignment done. Alright. Alright, so, okay, so we're going to start off with these few terms that are very closely related but do not mean the same thing. I have said that they mean the same thing before, but not exactly. Okay, so first we have a root, we have a zero, solution, an x-intercept, and a factor. Now, I'll tell you right now that whenever I talk about roots, zeros, and solutions, normally I mean the same thing. Okay, x-intercepts are related to those, and factors normally are related to them as well, but they're not exactly the same thing. But yeah, I guess let's go ahead and see. Okay, so some distinctions to make. Okay, so a root, a zero, or a solution refers to the x value at which a polynomial equals to 0. So basically, if you have a function f of x and you set it equal to 0, whatever x values you need to make that function equal to 0, or whatever values of x you need to plug in to make that function equal to 0, those are your roots, zeros, and solutions. Okay. Now, a factor is a little bit different. It uses roots, or it uses the zeros and solutions. Okay. A factor of a polynomial is an expression in the form x minus r, where r is a root of the polynomial. So if one of the zeros is like x equals 3, then one of the factors is actually x minus 3. Okay. If one of the factors, if one of the zeros is x equals -4, well, in that case, one of your factors is x minus -4. But because we have a double negative here, we could just write it down as x plus 4. Okay. So basically, your zeros are the negatives of whatever is inside of the factor. Okay. So if it's positive 3, it becomes -3. If it's -4, it becomes +4. Okay. You want to remember it like that. Alright, and then your x-intercepts. Okay, your x-intercepts are pretty easy. Normally these deal with graphs. They're the points at which the graph of the function touches the x-axis. Okay, so if you don't remember what your x and y axes are, x is this one, y is this one, and basically anywhere where it touches on this line, those are your x-intercepts. Okay, now, one thing you have to realize is that the x-axis is at y equals to 0. So if you plot the function y equals to f of x, well, then you're just getting the zeros or solutions of that problem. Okay. Now, you won't always have x-intercepts be equal to the solutions. Sometimes you're going to have imaginary solutions or complex solutions. This is what I talk about here. Okay, so now remember those numbers that we worked at the beginning of all the videos, where we had something like 3 plus 2i. Well, those are complex solutions. Okay, those are pretty important for polynomials. Okay, and normally these imaginary solutions are not graphed. Okay, so even if a problem has an imaginary solution, you might not be able to tell from just a graph. Okay, so alright, so your x-intercepts lie wherever your zeros are. So right here, the point 2, 0 and -2, 0, those are your x-intercepts. But the solutions for this problem, for this equation or this function, are x equals -2 and x equals 2. These are your zeros, or your solutions, or also called your roots. Okay, now your factors, from what I can tell here, are going to be x plus 2 because of the -2. Remember, we're subtracting it, we're just basically changing that value, and then x minus 2 right there. Okay, now the next one, does it have any x-intercepts? No, no x-intercepts. So from what I can tell here, at least, I can't tell whether it has solutions. I can't tell that it has roots, or at least real roots. It might have imaginary roots or complex roots. And I can't tell what factors it would hold whenever we set up the equation. In fact, it might not have factors like this. It might have factors like this instead. Plus 2, minus 2 plus 3i. Okay, so it might have complex factors like this. Okay, now the last one, this one right here, has 3 x-intercepts. Okay, and you can have as many x-intercepts as you want. Well, as the equation will let you have, really, but we can have more than 2. We can have 0, we can have 3, we can have 4, we can have 5, depending on what the degree of the polynomial is. But I'll talk about that later. Okay, so what I can tell here is that we have 3 factors at least. Okay, I'm going to start off with that. X plus 1, x minus 1, and x minus 2. Remember, you change the sign of whatever the 0 is. Okay, that means that your zeros are going to be at x equals to negative 1, x equals to 1, and x equals to 2. Okay, and then finally, excuse me. And then finally we have, what was it? I'm sorry, I lost track of it. Oh, our x-intercepts, yeah. Sorry, I don't have a script for these. I just kind of go along with it as I would normally in class. And hopefully they all work out. I hope you guys aren't too confused by my wording. I do sometimes try to re-record them, that way they don't sound too bad. But let's go ahead and look at, let's go ahead and look at this function. Okay. Let's say you had a problem like this. I told you f of x equals x squared plus 6x minus 7, and they asked you what the factors are, or what the roots are, or what the zeros are, or what the solutions are, or what the x-intercepts are. How do you figure that out? What should your answers look like for each one of these? Well, for factors, we should know how to factor at this point. Okay, because we have a 1 right here in the front. Okay, that means all we have to do is take a look at the number in the back. We factor it out. Negative 7. What numbers give you 7 whenever you multiply them? Well, 1 and 7, and because it's a prime number, that's basically it. Because it's a negative number, we need one of these values to be negative, so that whenever we add them up, we can get the positive 6 that we need right here. And that's pretty easy to tell. We're going to need the 1 to be negative, because once you add negative 1 plus 7, that'll give you 6. And these are going to be the values that we use for the factors. So we'll have x minus 1, x plus 7. Awesome. All right. For your roots, we got to change those values up. You got to take x equals to positive 1, x equals to positive 7. Okay, now normally the way you would get your root zeros and solutions is that you take your factors, x minus 1, you set them equal to 0, x plus 7, you set it equal to 0, and you solve for these. Okay. Now, you're not always going to be able to just take these values from the factors and just change their sign and set them and just say that that's what the roots are. Okay. And let me do this one. X equals negative 7. Oops. I guess that looks more like, yeah, okay, there we go. The negative 7 right there. And sometimes I write down my 7s like this. Actually, you know what? Let me make that a bit more clear. That should be a negative 7, guys. Okay, negative 7 right there. Alright, so, okay, so we understand that once we solve for each one of these factors set equal to 0, we can get our roots. That's also how we get the zeros, which are the same values. And the same thing as our solutions. X equals 1, x equals negative 7. Okay, now our x-intercepts, we want to use points for these. Our x-intercepts are always going to have y values equal to 0. and they're going to have an x coordinate, which are just going to be equal to our roots or zeros or solutions, 1 and -7 here. Okay. So our x-intercepts are 1, 0 and -7, 0. Okay. Our roots, zeros, and solutions are all the same values, and our factors just take those values and make them negatives of what they already are. They change the signs. You're not always going to have factors like this. Sometimes you're not going to be able to factor something out. But if you know solutions, sometimes you'll be able to write them out differently. What do I mean by that? Okay. Let's say we had this problem, x squared plus 4x plus 8. Alright? And we want to figure out the same exact questions. What are your factors, what are your roots, your zeros, and what are your x-intercepts? I guess I meant the solutions too. Sorry, I guess I missed out on that. Because there's a 1 in the front, we just take a look at the last number, 8, and look at the factors. The way you get 8 is by taking 1 and 8 and multiplying together. 2 and 4. 4 and 2, but we already wrote that down, and that should be it. Okay, now if any of these add up to the middle value, which is a positive 4, well then we use those in the factors. We have 1 and 8, which is 9, 2 and 4, which is 6, and it turns out that this one does not have any factors this way. Okay, that doesn't mean it doesn't have any solutions. That doesn't mean it doesn't have roots or zeros. And for now, we can say that we don't know what the x-intercepts are. Okay, because this is a quadratic. The way we get the solutions is actually by taking by using the quadratic formula. Let me start that off differently. If you don't remember what the quadratic formula was, write it up over here. It's going to be equal to negative b plus and minus the square root of b squared minus 4 times a times c divided by 2a. Remember, this is the quadratic formula. Okay. And those are your solutions to a quadratic problem or a quadratic equation. So it's basically the solution to this equation. Okay. Our b is 4, our a is 1, b is 4, and c is equal to 8. All I have to do is replace these values and make sure that I write them in correctly. Okay, and punch them in correctly into a calculator if I'm going to use a calculator. So I'm going to go ahead and use b as 4. So we'll have negative 4 plus and minus the square root of 4 squared minus 4 times a, which is 1, times c, which is 8, divided by 2 times 1. I'm going to go ahead and simplify all of this. Negative 4, 2 at the bottom, plus and minus the square root of, well, 4 squared is 16, and negative 4 times 1 times 8 will become negative 32, so I'm going to write that down. Okay. Another way of doing that was to just take 4 times 1 times 8 and leaving the minus as it is. Okay. And that can be further simplified into negative 4 plus and minus the square root of negative 16. Notice that we have a negative inside the square root. If you guys remember, whenever we took the square root of negative numbers, we end up getting errors on our calculator. Okay, this is because normally your calculator can't take the negatives because it can't give you complex solutions back. What this is actually going to do is it's going to give you an imaginary number. Anytime you take the square root of a negative number, it's really an imaginary number. So to get rid of that error, or to get rid of that negative inside of the square root, all we have to do is take the square root of the number inside of it without the negative and just put a little I on the outside of the square root to indicate that it's a imaginary number. Now, if you guys remember, complex numbers, they have a real part. Okay, that's this part right here, and they have an imaginary part. They do not mix. Okay, they're oil and water, apples and oranges. Okay, you do not want these to mix up. So we're going to take each one of these numbers and we're going to divide them by 2 individually. Negative 4 divided by 2 is going to become negative 2. That plus and minus symbol is still going to stay there. And then square root of 16, well, that should be 4. The I doesn't get divided. You only need to divide one of the numbers whenever you're dividing one term. Okay, so we have negative 2 plus and minus 4i. Okay. Oh, actually, sorry. That's my mistake. Square root of 16 is 4, so I'm just going to cancel that out and write it down as 4. And then 4 divided by 2 is 2. I'm sorry I don't correct these mistakes, guys. The videos just take a little bit too long to re-record at this point. Alright, so we have negative 2 plus and minus 2i. So that means that your answers are going to be x equals to negative 2 plus 2i and negative 2 minus 2i. So your solutions are exactly that. X equals negative 2 minus 2i and x equals negative 2 minus 2i. What are our factors? Well, we couldn't factor this out, but we can actually write in some factors for these. X minus negative 2 minus 2i. And you can do this any time that you have solutions that cannot be gotten from factoring. So if you use the quadratic formula and you still got numbers that were not imaginary, you can do the same thing here. You take x and you subtract your solutions or your roots. X minus our other solution, which was negative 2 plus I. Negative 2 plus 2i. Sorry, I know I misspoke there. The roots are still the same thing as our solution, so I'm going to put that in. Okay, so what about the x-intercepts? Okay, we used the solutions before for our roots. We used them for our factors, but can we use these for our x-intercepts? Actually, no. Complex solutions do not give you x-intercepts, because if we were to graph this, the actual graph would look something like this. Like that. And that actually does not have any x-intercepts, so in this case we say no x-intercepts, even though we have solutions and even though we have factors. Okay, it's going to be something tricky to figure out, but eventually I know that you guys can remember it. Alright, let's continue. Okay, so complex solutions to a polynomial. Okay, so here's some extra information about these. They include an imaginary part and they include a real part, which can be equal to 0. So some of your solutions could be something like 2 plus 3i. This is your real part. This is your imaginary part. Basically, the part with an I, that's your imaginary part. The part with no I, that's the real part. Okay, and they could be pure imaginary solutions. So we can have just a solution that's like this. Okay, that means that the real part is a 0. So we could have written that like this. Right. Now, complex solutions come in pairs. Okay, that means that you get 2 at a time. And those pairs are called conjugates. And they're not too hard to figure out. Basically, if you get a solution that looks something like this, you'll also get a solution that looks like this. So in the previous problem, look at what we did. Okay, so here's our solution, negative 2 minus 2i. Look at the other solution, negative 2 plus 2i. One of them has a minus, one of them has a plus. Okay, right here, one of them has a plus, one of them has a minus. Doesn't matter. Think of these as twin answers. Okay, so they come together. Okay, so here's the solution. Let's say we have an example. Sorry. Let's say f of x has a solution at x equals to 3 minus 4i. Well, if it has a solution at 3 minus 4i, then it also has a solution at 3 plus 4i. Okay, and if it was the opposite way, where this one was 4 plus, well, the same thing would be for a minus 1. Okay, so if we had 3 plus 4i, then our other solution would have to be 3 minus 4i. They come together. Okay. They're twins. They're born at the same time. Okay, alright, finally, we have the fundamental theorem of algebra. Okay, so this one's, I don't know, it's a little bit hard to explain, so I'll try to cut it short. Okay, so this is actually going to be how you figure out how many solutions a polynomial has. Okay, the fundamental theorem of algebra tells us that if a polynomial has a degree of n, then the polynomial has n solutions. Okay, which can be either a mix of either real solutions or complex solutions, and sometimes either one of those types of solutions are going to repeat. Whenever they repeat, they get counted more than one time. So what do I mean by that? Well, let's say we had the solution x equals to 4, and then we had the solution x equals to 4 again for an equation. Like we solved the factors and we end up getting x equals 4 and x equals 4 twice. Well, that just means that we have x equals 4 as our solution. You really only say it once, but we count them as two solutions because it came up twice. Okay. Alright. So, okay. And let's go ahead and look at this. So, this is using the fundamental theorem of algebra. If we took x to the power 4 minus 8, we know, because of it, that it's going to have 4 solutions. Okay, we don't know what they are yet, because we haven't solved for it, but we know that there's going to be 4. Okay, and out of those 4, they could be 4 real solutions. Okay, they could be 2 real and 2 complex solutions. And you might be thinking, why is it 2 real and 2 complex solutions? Well, remember I said that they come in pairs, so we can't really have an in between. We said, oh, it could be 1 complex solution. No, it can't be, because they come in pairs, so there has to be 2 whenever there's 1. Okay, so it can be 2 real or 2 complex, or it could be 4 complex solutions. It can't be more, it can't be less than those options. Alright. Oh, and I guess just to this is an extra tip over what I'm going to talk about later. The number of solutions a polynomial has affects the shape of the graph. Okay, you see, the number of solutions will tell you how many x-intercepts it might have. The degree of the polynomial is also going to affect it as well. Okay, so if you have like degree of 5, the shape of the graph is actually going to look different from the shape of degree 3 polynomial. Okay, but I'll talk about that later. Okay, let's talk about repeated solutions. Okay, the number of times that a solution is repeated is referred to the multiplicity of that root. And by the way, notice that I'm using these two words interchangeably. They still mean the same thing. So the solution is repeated is referred to as the multiplicity of that solution. That's it. Okay, so for the equation x minus 4 squared equals 0, well, x minus 4 times x minus 4 squared is just x minus 4 times x minus 4. Okay, if I wanted to get the solution to this, I just set each one of these factors equal to 0. Because of the zero product property, meaning that it can only equal to 0 if and only one or both of these factors equal to 0. So they only equal to 0 at these values, which are x equals 4 and x equals 4. So that means x equals 4 has a multiplicity of 2 because it repeats twice. Alright, so let me go ahead and erase that so that you guys can see. Okay, so you have the solution x equals 4 twice. This means that x equals 4 has a multiplicity of 2. That's what I just wrote down earlier. Okay, multiplicity can also affect the shape of the graph for a polynomial function. Okay. Now let's go ahead and talk about the shape of the graph. Okay. The solutions tell you where the x-intercepts are found. Okay. Sometimes if you have imaginary solutions, it just tells you that you're not going to have x-intercepts. Okay. The number of solutions, whether they're real or complex, will tell you how many times the function will switch its slope. In other words, right here what I actually mean is the degree of the polynomial. Okay, not really the number of solutions. So the degree of the polynomial will tell you how many times it goes up and how many times it goes down. Basically, it changes its direction eventually. Okay. The multiplicity will affect the shape of the graphs around the x-intercepts. Okay, so this is pretty important. I'm going to talk about this in a little bit. The leading coefficient will affect the end behavior. So let's say we have our x and y axis, and this could be a polynomial. Basically, the degree, or I mean the leading coefficient, will tell you whether it's going to point upwards in this direction, if it's going to point upwards in this direction, or if it's going to go this way, or if it's going to go this way. Okay, end behavior just refers to if you go to the left, which direction is it going to go? If you go to the right, which direction is it going to go? Is it going to go to positive infinity, or is it going to go to negative infinity? And the same thing this way. Positive infinity or negative infinity. That's what I mean by end behavior. Okay, and your degree will affect the end behavior as well. Okay, it affects the shape of the graph. It also affects whether it's going to go up or down, or up this way or down this way. Okay. All right. So the number of solutions will tell you how many turns the graph is going to have. So this is more about the degree. Okay. Remember, through the fundamental theorem of algebra, if we had something like x power 4 minus 3x plus 2, we have to look at the degree. It tells me that it's 4 solutions. But what it's also going to tell me is that we're going to have 4 minus 1 turns. So I already kind of know what this graph should look like. So let me go ahead and... I'm so sorry for my non-straight lines. You can laugh at me from home. Okay. That's terrible. That's... Alright, so we'll have 4 minus 1, which is 3 turns that we're going to do. Okay, so this graph is going to look more or less like this. Let's say, you see it's going to go that way, then it's going to turn 1, 2, 3 turns, and then it's going to look something like this. Okay, so this expression right here, because it has a degree of 4, it takes 3 turns before you decide the end behavior. Okay, let's say we talked about another one. Let's do this one in blue. Okay, let's say we had x power of 6. Well, no, not 6. Let's do 3. Okay, minus 2x minus 5. Okay, this number is usually going to tell you the y-intercept. So I know that it's going to go at minus 5. It's going to touch right here somewhere. Oh, and look. Oh, this one's really bad. But it should have touched right here somewhere. Or the plus 2. Because that's the y-intercept. Okay, so sorry about that. Alright, so it's going to touch at minus 5. But it's 3. So it's going to have 3 turns. I kind of already know what this is going to look like. Okay, so I'm kind of estimating here, but I would say, oh, it has 3 minus 1 turn. Sorry, I think I said it has 3 turns. It only has 2 turns. Okay, so we're going to go this way. That's going to be 1 turn. That's going to be 2 turns, and then that's going to be about the shape of the graph. Okay, so that's what I mean by the number of turns. Okay, and it does affect the graph. If it had more than 2 turns, or if it had more than 3 turns, then it would be a higher degree polynomial. They can have up to this many turns. They don't always have to be exactly 3. They don't always have to be exactly 2 based on the the degree. But normally, if you can count them up, you'll know how many or what the degree could be. Alright, so parity, the even or oddness of the degree. This is actually going to tell you how the ends behave. Okay, so sorry again about my straight lines. Oof, this is so bad. Okay, just imagine those are straight lines. I'm sorry. Okay, so the parity of the degree, whether it's even, basically both ends will end in the same direction. So let's say this, on the left hand side, it goes this way. Whenever it's even, the right hand side will go the same way. It'll keep growing this way, it'll keep growing that way. Now, let's say it was odd. Let's change back to red. If it's odd, well then the graph will go in opposite directions. Maybe it'll go this way at the beginning, and then it'll go that way. Okay, different directions, different end behavior. Oh, it doesn't have in a U in the US, but whenever it's even, it has the same end behavior. Same end behavior. There we go. Okay, so whenever it's even, it has the same end behavior. That means that it can also be, let me change the color here. It could also be that they both go downward. Okay, or, and in the case of the odd one, because they both have different end behavior, meaning one side goes up and one side goes down. It could start off this way and then end this way. Okay. So now this is affected by the degree. Okay. So if it's odd, different directions. If it's even, same direction. Okay. If you don't remember what an even number is, it's basically multiples of 2. So 2, 4, 6, 8, 10, so on. Odd numbers are 1, 3, 5, 7, 9, 11, so on. Okay. Alright, let's move on. Okay, the real solutions. Oh, okay, so the real solutions are actually going to affect your x-intercepts. Okay. So whatever your roots are, whatever they equal to, if they are real solutions, meaning that they don't have an imaginary part, that's where your x-intercepts are going to be. And we talked about that. Okay, so if we have, let's say we have a solution. Let's say we have a solution at x equals 5, at x equals -2, and x equals 0. Well, that means that at x equals 5, 1, 2, 3, 4, 5. Right here we have an x-intercept. At x equals to -2, we have an x-intercept, and at x equals 0, we have an x-intercept. So, in some way or form, our graph is going to go through those points. So it could look like this. It could look like this. Which is weird, or some sort of combination like that. It could be, let's do blue. It could look like this. It all just depends on the degree and some other factors, but you'll always know that because you have solutions at 5, -2, and 0, you'll have those x-intercepts there every single time. Yeah. Next slide. Okay, the multiplicity of real solutions. Okay, so this one's really important. Okay, it actually tells you what it looks like whenever you have x-intercepts, like here. Let's say these 3 points, which are x equals 2, x equals 0, and x equals -4. Okay, so now if let's say I said that each one of these had a different multiplicity. Okay, we'll say that x equals 2 has a multiplicity of 2. It repeats twice. X equals 0 has a multiplicity of 1. And x equals -4 has a multiplicity of 2 as well. Okay, so whenever you have an even multiplicity, it means that the graph is going to touch at that point, at that x-intercept. Okay, and I'll show you what that means in a little bit. Whenever you have an odd multiplicity, that means that your graph is going to cross at that point. Okay, so right here we have an example. This one is even, this one is odd, and this one is even. So what I know here is that my graph is going to touch at x equals to 2. It's going to cross at x equals to 0, and it's going to touch, only touch at x equals to -4. Alright, so let's start off with x equals -4. It says that it's going to touch. Okay, well, my graph is going to look something like this. It touched. Okay, at x equals to 0, it's going to cross. So it's going to go through that point, and then it's going to go over to the other side. It crossed. And then finally, for x equals to 2, it's going to touch again. So it's going to go up here. It's going to touch that point, and then it's going to go back down. Okay. So what I can tell here is that my graph is most likely going to be of odd degree. Okay. Odd because I know that this side is going up, this side is going down. They're in opposite directions. And if you guys notice, what was it? The parity of the degree. If it's even, then they go in the same directions, and if it's odd, they go in opposite directions. Okay. All right. Now, last thing that affects the graph is the leading coefficient. Basically, is it positive or is it negative? Sometimes the value, the size of it, is going to affect it as well. But that's only going to affect like the distance between points or the distance between values. Not really the overall shape of the graph. So, positive or negative. Well, what happens whenever it's positive? And what happens whenever it's negative? Okay, well, normally, let's say that the leading coefficient, and I'm sorry about the lines again. I need to get better at this. That's not even really visible. Let's change to red. I think that was a very clear color. Okay, so I'm going to show you examples of what a positive coefficient, leading coefficient, is going to do to a graph that's even, with a degree that's even. Positive degree is even. I'm going to say LC degree equals even. Okay. Well, if it's even, that means that both ends go in the same direction. This is basically what it means. It means that if you have a positive leading coefficient, both ends are going to go up. Okay, so an example of this could be something like 4x squared plus 2x plus 1. This is what it might look like. let's say we had a negative leading coefficient with a degree that's still even. Okay, so an example of this could be something like negative 4x squared plus 2x plus 1. Well, once you have that, let me change the color here so that you can differentiate. Although it's pretty clear what happens, or which one's which. Okay, so it might look like this, where both endpoints go downward. Okay, so if it's even and it's positive, the first number is positive, they both go up. If it's even and the first number is negative, well then both ends go down. Okay. Now let's go back, change this up, and we're going to be looking at odd degree and negative. Now, I guess we can start off with negative this time. Negative. Now, you know what? Screw it. Sorry, I just think it's better to start off with the positive one. Positive leading coefficient. Okay. Positive leading coefficient. Well, odd degree will look something like this. Okay, where both ends go in different directions. One of them goes up, one of them goes down, but the one on the right goes up, the one on the left goes down. Okay, so if you have an odd degree, you have a positive leading coefficient. This is what your graph might look like. Let's see, x power of 3 or 2x power of 3 plus 4x squared plus 2x plus 1. Okay, that might be an example of what this looks like. Okay. Now, if you have an odd degree, but you have a negative leading coefficient, well, it's just a small change. Okay, and it's that we'll basically flip it over. Let's say this is what your graph looks like. Okay, the left hand side is going to be going up and the right hand side is going to be going down. Basically, the right hand side always kind of matches with whether it's positive or negative. Okay, so if this value is positive, the right hand side goes up. If the value is negative, like let's say negative 3x cubed plus 2x squared plus 4, well, if the leading coefficient is negative, well then the right hand side is going to go down. And then you just determine whether the left hand side is going to be going up or down depending on the degree. Okay, that's basically the only change. I think this video is a little bit long, I'm sorry, but your homework is going to be short. Degree parity. Oh, whether it's even or odd. I think I already went over this. So I think we'll stop there. Hope you guys have a good weekend. Be awesome, stay safe, wash your hands, and see you guys next time.